500 million people eat this plant every single week. They press its seeds into an oil they drizzle over food the same way families in the American South use olive oil, the same way cooks in Northern Europe reach for butter. They have done this for over 2,000 years. The plant is not exotic to them. It is not a supplement. It is not a trend. It is a cooking staple so ordinary it sits on the counter next to the salt. And in the United States, almost no one knows it exists. The seed oil of this plant contains more alpha-linolenic acid by proportion than any other edible plant oil on Earth. More than flaxseed, more than chia, more than sacha inchi. A single teaspoon delivers the plant omega-3 equivalent of what Japan's Ministry of Health says an adult needs in a day. An entire industry worth just over $3 billion annually has positioned itself between you and that fact for decades. Before you understand what that means, you need to understand what the plant is, where it comes from, and what 40+ peer-reviewed studies actually show about what happens when humans consume it. The plant is called Perilla frutescens. In Japan's northern farm regions, it is called egoma. In Korean kitchens, the seed oil is dulce girium, the golden oil, the one grandmothers kept in ceramic jars and used to finish every bowl. In China, where its medicinal use was formally recorded in the Mingyi Bielu during the Western Han Dynasty over 2,000 years ago, it is called zisu, the character Z meaning purple for the color of its stem, and su meaning comfort for what it was said to give. In Vietnam, it grows wild along roadsides. In the classical Chinese pharmacopoeia compiled by Li Shizhen in 1578, it appears across multiple entries for conditions ranging from respiratory illness to seafood poisoning to what practitioners described as depression-related disease. This is not a plant recently discovered by nutritional science. It is a plant that nutritional science in the English-speaking world has systematically failed to investigate. Here is what the actual numbers show, and I want you to stay with these because the gap between what is known and what is discussed publicly is significant. Perilla seed oil contains between 54 and 64% alpha-linolenic acid by weight. That figure has been confirmed independently by researchers at the National Institute of Nutrition in India, by analyses published in peer-reviewed food chemistry journals, by Japan's own standard food composition tables maintained by the Ministry of Education, and by JETRO, Japan's government trade body, which lists it plainly: 60% alpha-linolenic acid by volume, the highest among all vegetable oils. For context, flaxseed oil, the plant omega-3 that health stores do sell, contains between 53 and 57% ALA. Chia seed oil reaches approximately 58 to 60% in cold-pressed analysis. Perilla is at the ceiling. No commonly available edible oil tested in standard nutritional analysis sits higher. Walnut oil is approximately 13% ALA. Canola oil, the omega-3 oil the food industry did successfully market to Western consumers, sits at 9 to 11%. Soybean oil at 7%. Read those numbers in the other direction. For the same volume of oil, Perilla delivers roughly 6 times the plant omega-3 of the canola oil in your cabinet right now. The omega-6 to omega-3 ratio is the figure that makes this extraordinary. The modern Western diet runs at approximately 15 to 20 parts omega-6 for every 1 part omega-3. Nutritional epidemiologists who have studied inflammatory disease patterns describe this ratio as one of the most significant dietary shifts in modern human history, a shift that began with the industrialization of vegetable oil production after World War II. Perilla seed oil runs at approximately 1 part omega-6 to 5 parts omega-3. The ratio is inverted. It is almost the precise mirror image of what most Western adults consume daily. Now, here is where the story becomes something different entirely. A search of PubMed, the primary English language database for biomedical research, returns more than 15,000 studies on fish oil omega-3. A comparable search for Perilla returns approximately 400. That is not a rounding error, that is a structural gap. Roughly 37 peer-reviewed studies exist on fish oil for everyone that exists on Perilla, despite the fact that Perilla has been consumed continuously by hundreds of millions of people for longer than modern nutrition science has existed as a field. The explanation is not complicated when you trace the money. The global fish oil supplement market was valued at approximately $3 billion in 2023, with projections reaching over $4 billion by 2030 at a consistent annual growth rate of nearly 5%. The industry is not distributed broadly across small players. DSM Nutritional Products, now part of the merged entity DSM Firmenich, held 26.64% of global omega-3 revenue market share in a single year. BASF held 12%. The top 5 companies in the space took nearly half of all global omega-3 production in the same period. These companies fund clinical trials. They fund systematic reviews. They fund the scientific consensus that reaches practicing physicians, dietitians, and health policy writers. The organization that coordinates their interests is called GOED, the Global Organization for EPA and DHA Omega-3s. Its stated mission, published on its own website, is to increase global consumption of EPA and DHA, not omega-3 fatty acids broadly, not plant-based omega-3s, specifically EPA and DHA, the forms found in fish oil. In a single year, GOED placed messaging in front of more than 300 million consumers. It lobbied regulatory bodies in 33 countries. It deployed 25 advertising campaigns targeting nurses, physician assistants, and pharmacists, generating more than 1.5 million professional impressions. Its public relations budget in 1 year alone exceeded $190,000 just for consumer-facing communications. No equivalent advocacy body exists for alpha-linolenic acid. No equivalent body exists for perilla oil. There is no organization spending money to make sure your doctor has heard of this plant. Marion Nestle, the food policy scholar who has spent decades documenting the relationship between industry funding and nutritional science, reviewed studies funded by GOED that were published in peer-reviewed journals and found co-authors who were GOED employees and paid consultants. She noted the association's mission explicitly and wrote plainly that this trade association for EPA and DHA supplements funded this study to demonstrate the benefits of these products. The International Society for the Study of Fatty Acids and Lipids, an academic body that counts major marine-sourced omega-3 suppliers among its members, published a formal statement declaring that ALA conversion to DHA in the human body is essentially negligible. Plant omega-3 researchers and the flaxseed industry pushed back immediately, noting what a former Pfizer scientist called the narrowness of a framing that focused exclusively on ALA's conversion shortcomings while ignoring its independently documented benefits. Here is what that framing left out. In 1994, a landmark French cardiovascular trial called the Lyon Diet Heart Study enrolled 605 patients recovering from a first heart attack and randomized them to either a standard Western prudent diet or a Mediterranean diet rich in ALA from canola oil margarine. The trial was stopped early, not because participants were being harmed, because the ALA-rich group was doing so dramatically better that the ethics committee ruled it inappropriate to continue withholding that dietary pattern from the control group. After 46 months, cardiac death and non-fatal heart attack had occurred in 14 patients in the ALA-rich group, compared to 44 in the standard group. A more than 60% reduction in combined events. When researchers analyzed which specific fatty acid in the blood was independently associated with cardiac protection, they found one, not EPA, not DHA. Alpha-linolenic acid was the only plasma fatty acid significantly associated with the reduction in coronary events. That study was published in The Lancet in 1994 and in Circulation in 1999. It is not obscure. It sits inside a 30-year body of evidence that the conversion narrative quietly sidelines. A meta-analysis published in a peer-reviewed nutrition journal found that each additional gram of ALA consumed per day is associated with a 10% lower risk of dying from coronary heart disease. A Dutch population study following over 20,000 men for 8 to 13 years found that individuals consuming more than 1 gram of ALA daily had a 35 to 50% lower risk of stroke. The Nurses' Health Study, tracking over 90,000 women, found a comparable inverse relationship between dietary ALA intake and sudden cardiac death, an effect that remained significant even among women already consuming adequate long-chain omega-3s from fish. These are not fringe studies, they are the same kind of large, long-duration, peer-reviewed population data that the fish oil industry cites when making its own cardiovascular claims. Now, I want to walk you through the clinical evidence that exists specifically for perilla, because it extends well past cardiovascular health and into territory the supplement aisle has never addressed. In 2004, researchers at Kyoto Prefectural University published a randomized, double-blind, placebo-controlled human trial in the journal Experimental Biology and Medicine. 29 adults with seasonal allergic rhinoconjunctivitis, hay fever, received either 200 milligrams of perilla extract, enriched for rosmarinic acid, 50 milligrams, or placebo, over 21 days. The results showed a statistically significant increase in responder rates for itchy nose, watery eyes, itchy eyes, and total symptom burden with p-values below 0.05 in both active groups versus placebo. Neutrophil and eosinophil counts in nasal lavage fluid, two direct markers of allergic inflammatory response, decreased significantly in the active treatment groups. No adverse events were recorded. The authors specifically noted that use of this plant extract as an alternative treatment for seasonal allergic rhinoconjunctivitis might reduce treatment costs for allergic diseases. That study has been cited nearly 200 times. It is not cited on the packaging of the antihistamines sold in every pharmacy in this country. The compound driving that effect, rosmarinic acid, is present in perilla leaves at an average of 5,647 milligrams per kilogram of dry weight, with variation by region and cultivar, reaching as high as 14,978 milligrams per kilogram. For reference, the Chinese pharmacopoeia sets a minimum standard for rosmarinic acid in perilla preparations, which means traditional medicine formalized what clinical science has only recently confirmed. Rosmarinic acid works through the same biological pathways that pharmaceutical anti-inflammatories target. It inhibits KIOX-2, the cyclooxygenase enzyme responsible for prostaglandin synthesis, the same enzyme that ibuprofen inhibits. But it also inhibits the lipoxygenase pathway, specifically 5-LOX and 12-LOX, which governs leukotriene production. Leukotrienes are a separate class of inflammatory signaling molecule that non-steroidal anti-inflammatory drugs like ibuprofen do not meaningfully touch. In laboratory work with rat platelets and human leukocytes, the lipoxygenase inhibitors isolated from perilla seeds showed IC50 values measuring their potency against the 12-LOX pathway in the nanomolar range. The dual pathway inhibition profile is mechanistically broader than a standard over-the-counter pain and allergy drug. A 2023 randomized controlled trial published in the Journal of Biological Regulators enrolled 90 patients with pollen-induced asthma and allergic rhinitis and added a perilla-containing nutraceutical to their standard pharmaceutical treatment. Compared to standard treatment alone, the perilla add-on group experienced a 39% reduction in nasal symptoms, a 32% reduction in bronchial symptoms, a 30% reduction in rescue inhaler use, and a 41% reduction in nasal corticosteroid use. Lung function by FEV1 measurement improved by 10%. All comparisons reached a p-value below 0.0001. There is also a cognitive dimension to this story that the research is only beginning to surface. A 12-month randomized, double-blind, placebo-controlled trial in 75 healthy, elderly Japanese adults, published in the journal Foods in 2021, found that perilla seed oil administered daily improved scores on the frontal assessment battery, a validated cognitive function test, and improved apathy measures compared to a control group. The mechanism appears to be direct. ALA crosses the blood-brain barrier. A 2017 study in the Journal of Agricultural and Food Chemistry directly compared ALA from perilla oil to DHA in an Alzheimer's mouse model, administering both at 100 milligrams per kilogram per day for 14 days. ALA prevented learning and memory deficits on the T-maze, novel object recognition, and Morris-Water maze tests at a level the researchers described as comparable to those exerted by DHA. ALA also regulated amyloid precursor protein processing. It upregulated the non-amyloidogenic pathway through ADAM10, and it downregulated BACE1, the beta secretase enzyme central to amyloid plaque formation. The paper concluded that ALA might be a potential candidate for prevention or treatment of neurodegenerative diseases such as Alzheimer's. Separately, an epidemiological study cited across multiple Parilla cognition trials found that serum ALA level was independently and negatively associated with the risk of disabling dementia. These are not preliminary observations. They are peer-reviewed, methodologically rigorous studies, and they are absent from the consumer-facing nutritional conversation in the United States almost entirely. Here is the part of the story they do not explain in the gaps between supplement labels and dietary guidelines. Parilla was tested in the United States as a commercial oilseed crop. The first documented trial dates to 1911. American agronomists ran the economic calculations in 1911 and again in 1926 and determined it was unprofitable compared to linseed. A 1945 USDA report concluded that while Parilla was agronomically well suited to the southeastern United States climate, commercial production would be unprofitable unless the plant's natural tendency to shatter its seeds at harvest could be controlled. US imports of Parilla seed oil from Japan peaked at more than $2 million in 1939. The last recorded import shipment was in 1943, interrupted by the war. It was never commercially revived. Think about what that means. A plant with the highest documented plant omega-3 concentration of any edible oil, with 2,000 years of documented therapeutic use, with peer-reviewed clinical evidence for cardiovascular, allergic, and cognitive benefits, was evaluated in the United States, found inconvenient to harvest at commercial scale, and then quietly dropped from the agricultural conversation. Not banned. Not studied and rejected. Dropped because it could not be made profitable enough at the time, and because a self-seeding plant that someone can grow in a container on a balcony and press at home with a mechanical oil press cannot be patented, cannot generate repeat sales, and cannot support the infrastructure that nutritional research funding requires. Japan did not drop it. In Japan, Parilla oil is a standard item in the cooking oil section of major supermarkets. It is listed in the Japanese Pharmacopoeia, 18th edition. Japan's Ministry of Health, Labor and Welfare sets formal dietary reference intakes for omega-3 fatty acids, with Parilla oil recognized as the highest available plant source. Japan's Consumer Affairs Agency has a registered functional food designation, registration number G176, for a cold-pressed Parilla oil product whose approved health claim addresses blood pressure in people with mildly elevated readings. Japan's government trade promotion body, JETRO, states that the recommended daily intake of DHA and EPA equivalent can be met by 1 teaspoon of Parilla oil. Not a prescription, not a supplement protocol. 1 teaspoon. In the European Union, Parilla oil sits on the EFSA Botanical On Hold list. No authorized health claims are available under EU food regulation. Any European food brand selling Parilla oil must position it only as a source of omega-3 fatty acids without making specific health claims, under penalty of prosecution, because the EU evaluation framework has been suspended since 2010 with no resolution. In the United States, no qualified health claim has been authorized by the FDA for Parilla oil, despite individual product batches having cleared FDA inspection. There is no GOED equivalent for ALA. There is no industry body lobbying 33 countries to increase consumption of Parilla oil. There is no 300 million consumer messaging campaign. There is a plant, there are studies, and there is the gap between them. Korea still understands this intuitively. Annual domestic production of Parilla seeds in Korea is approximately 40,000 metric tons. Parilla oil, dilke girum, it appears in historical records of the Joseon dynasty royal kitchen. The first mention of Parilla cultivation in Korean medicine appears in a 15th century medical text published during the reign of King Sejong. The traditional efficacies documented in the Korean Traditional Knowledge Portal include promoting circulation, removing cold pathogens, soothing seafood poisoning, and preventing miscarriage in pregnant women. These are not folk myths that predate evidence. They are documented observations that subsequent clinical science has, in multiple cases, confirmed. Now, I want to be precise about one thing before we talk about growing and using this plant. The ALA conversion debate is real. The human body converts ALA to EPA at approximately 8 to 21% efficiency depending on sex, with women showing higher conversion capacity. Conversion from ALA all the way to DHA runs below 1% under normal dietary conditions in most studies. The fish oil industry uses this fact as its central argument. What that argument omits is the Lion Diet Heart Study evidence, the stroke risk data from 20,000 Dutch men, the sudden cardiac death data from 90,000 American women, and the Alzheimer's mouse model where ALA performed comparably to DHA on every memory endpoint. It also omits an 8-week randomized controlled trial in hypercholesterolemic human subjects where perilla oil supplementation reduced serum LDL cholesterol by 12% and total cholesterol by 8% compared to placebo. The conversion rate to DHA matters for some applications. It does not determine the full story of what ALA does inside a human body. A 12-month clinical trial in adults published in Foods found that perilla oil supplementation increased beneficial lactobacillus bacteria in the gut while decreasing Blautia, a genus associated with metabolic dysfunction in several inflammatory disease models. The first human microbiome evidence for perilla appeared in the British Journal of Nutrition in 2023 from a randomized trial in female athletes. The research is young. The plant has been consumed by 500 million people for a very long time. Here is the full setup for growing it at home. Use any container at least 12 inches deep and 12 inches wide. A standard 3-gallon pot works. Fill it with well-draining soil, slightly acidic if possible, pH between 5.5 and 7. Press seeds gently onto the soil surface and do not bury them. Perilla seeds require light to germinate. Place the container where it receives at least 6 hours of direct light daily or supplemental grow light indoors in a south-facing window. Keep the soil consistently moist without waterlogging. Perilla performs best at temperatures between 65 and 80 degrees Fahrenheit. At these conditions, germination occurs within 7 to 21 days. Leaf harvest is possible from 45 to 60 days onward. A single healthy plant yields between half a pound and 2 pounds of leaves across a growing season. For seed oil extraction, you need the variety grown primarily for seeds, not the ornamental shiso grown for leaves. The seed-bearing variety is labeled egoma in Japanese markets or dulce in Korean ones. You need a cold press. Small batch domestic oil presses capable of handling 2 kilogram seed loads at ambient temperature are available. Traditional Korean practice roasts seeds gently before pressing only to the point where moisture is removed, at around 100 to 115 degrees Celsius, not higher. Lower roasting temperature preserves more ALA. Oil should be stored immediately in dark glass, refrigerated, and used within 3 to 4 months. Now for the culinary piece, because this is where the research touches the everyday. The leaves are used across Korean, Japanese, and Vietnamese cooking in ways that differ from any Western herb. In Korean cuisine, fresh leaves wrap grilled meat. They are also marinated in sesame oil, soy, and garlic, and eaten directly with rice. In Japanese cooking, the green variety called shiso is the leaf under fresh sashimi, inside hand rolls, shredded into cold noodles, and steeped into cold drinks. In Vietnamese soups, it appears whole alongside basil and mint. The flavor is unlike anything currently common in Western cooking, a deep herbal complexity that crosses the registers of anise, mint, and something darker, more resinous that disappears on heat. The oil, finished cold over food after cooking, is how the omega-3 content is delivered without degradation. ALA is highly sensitive to heat and oxidation. The traditional practice across Korea and Japan of pressing fresh oil, using it within weeks and finishing dishes rather than frying with it is nutritionally correct. Cold over rice, over warm soup at the moment of serving, over fermented vegetables, 1 teaspoon per meal. This is not a dramatic preparation. It is a practice that has been completely ordinary to 500 million people across East Asia for a very long time. The science documenting what that practice does inside the human body now spans clinical trials in allergic rhinitis, asthma, cardiovascular risk markers, cognitive function in the elderly, gut microbiome composition, and direct Alzheimer's-related protein regulation. The research base is not large by the standards of fish oil. It is 37 times smaller by study count. But what exists is consistent, methodologically sound, and published in peer-reviewed journals that include the British Journal of Nutrition, the Journal of Agricultural and Food Chemistry, Experimental Biology and Medicine, Foods, and the Journal of Biological Regulators. The final thought is this: the distance between what this plant demonstrably does and the cultural invisibility it occupies in the English-speaking world is not explained by the science. The science has been clear since at least 1994, when the Lion Diet Heart Study made ALA's cardiovascular independence impossible for any honest reader to ignore. The distance is explained by the economics of what gets funded, what gets studied, what gets lobbied into dietary guidelines, and what gets marketed to the 300 million consumers an industry trade body can reach in a single year with a focused messaging campaign. The perilla seed cannot be patented. The plant self-seeds. It grows in a container on a balcony in any temperate or warm climate in the world, matures in 60 days, and presses into an oil at home with a tool that costs less than most bottles of premium fish oil supplements. There is no recurring revenue in that. There is no supply chain to protect. There are only the people across Japan, Korea, China, Vietnam, and a dozen other countries who have known this for 2,000 years. And the research base, quiet but consistent, that has been telling the same story in the language of peer review. 500 million people eat this plant this week. The only variable is whether you decide to be one of them. If this video shifted something in how you look at the plants around you and the industries between you and them, subscribe to Root Vault so you do not miss what we cover next. There are more of these stories, plants with centuries of documented use, clinical data in journals most people never read, and no one with a financial stake in making sure you find them. Leave a comment below with the next plant you want us to go this deep on. We read every one.